Alright everyone, welcome back. In our last session, we talked about what cloud networking is and why it's so fundamental. Today, we are going to roll up our sleeves a bit and dive into the actual basic building blocks of cloud networks. Our objective for today is to understand these core components that make up your virtual network. Let's start with the big picture, the virtual private cloud or VPC. Imagine you're moving into a massive shared office building. That's the entire cloud provider's infrastructure. Now you don't want your office space to be open to everyone, right? You want your own dedicated floors or different floors with your own walls, doors, and private utilities. That's exactly what a VPC is in the cloud. It is your isolated virtual network space within the cloud, even though you're sharing the same underlying physical hardware with the countless other companies. Your VPC provides a logically separate and secure environment for your resources, your virtual servers, databases, and applications. No one else can directly access your VPC unless you explicitly allow them to. It's your own private corner of the internet. So now this massive cloud office building isn't just in one city. It's spread across the globe. This brings us to regions and availability zones. A region is a geographical area. Think of it as a major city where the cloud provider has a presence like East US or Europe. Within each region, there are multiple isolated locations called availability zones, often abbreviated as AZs. Think of it as a separate data centers within that city designed to physically distant enough to be isolated from common failures like a power outage in one part of the city, but they are close enough for low latency connections. Why is this important for networking? Because you will typically build your VPC within a specific region, and then you place your network components and services across multiple availability zones within that VPC. This is a key for resilience and high availability. If one data center or one AZ has an issue, your application can still run from another AZ within the same region. So you have a private floor in a cloud networking or your VPC. Now within your office, you want to organize things, right? You have a marketing department, an engineering department, and a finance department, each in their own section or room, right? In cloud networking, we use subnets to do exactly that. Subnets are smaller logical segments within your VPC. You can create different subnets for different purposes. For example, a web server subnet where public-facing web servers live, a database subnet for your sensitive databases, which you might want to keep more private. This segmentation helps with security and organization, allowing you to apply different network rules to different groups of resources. Every device connected to network needs an address, right? Just like every house needs a street address. In the cloud, we primarily deal with two types of addresses, private IPs and public IPs. Private IPs, these are the addresses that are only reachable within your VPC. Think of them like an internal office phone numbers. You can call a colleague in the same building using the extension, but that extension does not work from outside, right? Most of your cloud resources like your database servers will only have private IPs for security. Public IPs, these are the addresses that are reachable from public internet. These are like your main company phone number that customers call, or it's like your mobile phone number which can be reached out from anywhere in the world. If you have a web server that needs to be accessed by users on the internet, it will need a public address. So now this brings us to a slightly more advanced but crucial concept, network address translation or NAT. Imagine your office has a single outgoing phone line for all internal phones. When someone inside makes an external call, the call appears to come from that main line. NAT works similarly for your cloud resources. NAT allows instances of the private IP addresses which can't be directly talked to internet to initiate outbound connections.